You know what's strange? Really strange. Not in the dramatic sense where something explodes or collapses, but in a quiet way that only reveals itself if you sit with it long enough, is that there exists something right now, something real, something we built with our own hands, that has already gone so far away from everything you recognize that if you were standing next to it, you wouldn't see the sun as the sun anymore. You would just see another faint point of light among thousands, indistinguishable, unremarkable. And the idea of home would begin to dissolve into something abstract, something that no longer has a clear direction attached to it, because distance at that scale doesn't just stretch space. It stretches meaning itself until it becomes difficult to hold on to. And here's the part I want you to really focus on, because this is where the story stops being about astronomy and starts becoming something personal, something that reaches directly into how you think about connection and permanence. That object is not coming back. It cannot turn around. It cannot slow down in any meaningful sense. And no matter what happens here, no matter what we invent or how advanced we become, we will never reach it again in any practical way. Not because it is impossible in principle, but because the scale of the problem quietly grows beyond anything that matters to a human lifetime. And yet it is still out there, still moving, still carrying a fragment of us into a region where nothing is waiting for it, and no one will ever witness its arrival. I am talking about Voyager 2. And if you think this is just another story about a spacecraft drifting through space, then you are already missing the point. Because this is not really about the machine itself. It is about what happens when something we created crosses a boundary we barely understand and continues long after it has any functional reason to exist. Because right now it is more than 20 billion kilometers away from you, moving through a region where the influence of the sun is no longer dominant in the way your intuition expects, where sunlight becomes thin, where the solar system itself begins to lose its identity. And every single year, without exception, it becomes a little weaker, a little quieter, a little closer to the moment when it will send its final signal and then fall silent forever. But don't imagine that ending the way you might expect. Don't picture an explosion or a collision or anything that provides a sense of closure, because that is not how this story works. And that is precisely what makes it unsettling if you really think about it. Because Voyager 2 is not going to end in a visible event. It is going to fade, slowly and quietly, losing energy bit by bit like a candle burning in a room where no one is watching, until one day the signal simply does not arrive, and there is no announcement, no final message telling you that this is the last transmission. Just an absence that stretches outward faster than anything we can respond to, leaving behind a silence that no action on earth can reverse. And here is where I want you to pause again, because this is the part most people never fully process, even after everything has shut down, even after every instrument has gone dark and every system has failed. Voyager 2 will not stop. It will not drift into some final resting place, because there is no such place waiting for it out there. It will continue moving through the darkness between the stars for longer than human civilization has existed, longer than recorded history, longer than anything you can easily grasp without your intuition starting to break apart. And it will do that completely alone, as a piece of metal and circuitry carrying nothing but the fading echo of a signal that once connected it to you. So the real question is not just where Voyager 2 is going, because that is something physics can answer with equations and trajectories. The real question, the one I want you to keep in the back of your mind as we move forward, is much simpler and much harder at the same time. What does it mean that we built something that will outlast our ability to ever hear from it again? Something that will continue traveling long after it has stopped being useful, long after it has stopped being alive in any meaningful sense. And yet we still chose to send it, knowing from the very beginning that this is exactly how the story would end. Let me ask you something, and I don't want you to answer too quickly, because if you do, you'll miss what's actually strange about it. What if I told you that one of the most ambitious journeys humanity has ever carried out did not succeed because we built a more powerful engine, or discovered some exotic new material, or unlocked a piece of advanced technology, but because of timing, pure timing, the kind of timing that you don't control, the kind that happens whether you are ready or not. And if you miss it by even a few years, the entire opportunity simply disappears for generations. That should bother you a little, because we like to believe progress is something we command, something we design and refine until it bends to our will. But in this case, the greatest advantage we had was already written into the motion of the solar system long before we ever thought to take advantage of it, because far beyond your everyday experience, beyond the orbits you casually picture, the giant planets Jupiter, Saturn, Uranus, and Neptune had slowly, quietly arranged themselves into a configuration so rare that it occurs only once every 176 years, forming a kind of temporary pathway through the outer solar system that, for a brief window, could be used to go farther than any spacecraft had ever gone before. Now, I want you to stop thinking of these planets as static points in a diagram, because that will lead you in the wrong direction immediately. And instead imagine them as massive moving bodies, each one carrying enormous momentum, each one bending space around it through gravity, each one capable of reshaping the trajectory of anything that passes close enough, and if you approach them in exactly the right way, not too fast, not too slow, not at the wrong angle, then something remarkable happens. You don't just pass by, you borrow energy. The planet pulls you in, curves your path, and then releases you again. But now you are moving faster than before, not because you used fuel, but because you understood how to fall correctly within a system that was already in motion. This is the idea of a gravitational assist. And it sounds simple when you describe it after the fact, but its power lies in something deeper, because it means that motion is not just something you carry with you. It is something you can exchange, redirect, amplify. If you are willing to think of the solar system not as a collection of destinations, but as a dynamic network of interactions, and that shift in perspective is what transformed Voyager 2 from a mission that could have ended after visiting one or two planets into something far more ambitious. Something that could extend itself step by step, using each encounter not as an endpoint, but as a transition to the next. Originally, the plan was modest by comparison. Fly past Jupiter, then Saturn, gather data, send it back, and conclude the mission, which would have been a success by any reasonable standard. But once scientists realized that the planets were aligned in this rare arc, a completely different possibility emerged. Not just two worlds, but four. Not just a mission measured in years, but one that could stretch across decades, not by adding more fuel, but by using what was already there, hidden in the structure of the system itself. And here's something I want you to really notice, because it is easy to overlook if you focus only on the scale of the achievement. The spacecraft itself did not become dramatically more powerful. There was no sudden leap in capability, no redesign that changed its fundamental limits. What changed was the way we understood the environment we were already in. the realization that the solar system was not something to be crossed with brute force, but something to be navigated with precision, patience, and timing. And that is a very particular kind of insight. The kind that tells you the universe often offers possibilities that remain invisible until you learn how to look at them correctly. So Voyager 2 was placed on a trajectory that from the outside might appear almost accidental. A path that curves and bends through space in a way that seems indirect, but in reality is extraordinarily precise, because each encounter had to occur at exactly the right moment, with exactly the right geometry, so that the energy gained from one planet would carry it to the next. And that sequence is not something you can reproduce at will, because once that alignment passed, it would not return for nearly 2 centuries, long after the people who designed the mission were gone. And that means something important, something I want you to carry with you as we continue. Because Voyager 2 was not just a machine traveling through space. It was a machine riding a moment in time, a very specific configuration of the solar system that existed long before we arrived and will exist again long after we are gone. And everything that followed, every image, every measurement, every discovery, depended on the simple fact that for a brief window, the universe arranged itself in such a way that if we moved at exactly the right time, we could go farther than we had ever imagined possible. If you had asked someone before the journey began what the outer solar system would be like, the answer would have sounded reasonable, almost obvious. Because far from the sun, where light is weaker and energy is scarce, you would expect quiet worlds, slow processes, objects that formed long ago and have simply remained there, unchanged, like cold archives preserving the early history of the system. And that idea feels so intuitive that it is easy to forget. It was never really tested in detail. It was an assumption, a clean picture built from distance rather than observation. Then Voyager 2 arrived, and instead of confirming that picture, it began to dismantle it. Not all at once, not with a single discovery that forced an immediate rewrite, but gradually, piece by piece, as each encounter revealed something that did not quite fit, something that made the previous explanation feel incomplete in a way that was difficult to ignore, because the data coming back did not describe a quiet system at all. It described activity, motion, instability, processes that were still unfolding in environments where, according to our expectations, almost nothing should have been happening anymore. There is a moment in exploration where you realize that what you are seeing is not just new information, but a challenge to the way you have been thinking. And that moment appeared when evidence began to show that bodies we had assumed were geologically inactive were in fact dynamic, surfaces changing, material being ejected into space, energy appearing where there should have been very little. And that forces a shift in perspective, because now the question is no longer simply what these worlds are made of, but what is driving them. What source of energy could sustain such activity so far from the sun, where solar input alone is insufficient to explain what is being observed? And once that question enters the picture, it spreads, because you begin to notice that these worlds are not isolated systems. They are connected, linked through gravity in ways that continuously reshape them, pulling, stretching, compressing, generating heat not from external radiation, but from motion itself, from tidal interactions that convert orbital energy into internal friction. And suddenly the outer solar system no longer looks like a collection of separate objects, but like a network a system where energy flows through relationships rather than being supplied from a single dominant source. What makes this even more unsettling is that the closer you look, the less willing the system becomes to fit into simple categories, because structures that appeared straightforward from a distance reveal layers of complexity, rings that are not uniform but shaped by countless small interactions, atmospheres that behave in ways that resist easy prediction, magnetic fields that do not align neatly with rotation. And each of these details adds another piece to a picture that is becoming increasingly difficult to simplify, as if the act of observing more closely is not clarifying the system, but revealing just how much of it was hidden by our earlier assumptions. By the time Voyager 2 moved deeper into the outer regions, the idea that there was a standard way planets should behave had already begun to dissolve, replaced by something less comfortable but far more accurate: the recognition that each world could be fundamentally different, not just in scale or composition, but in the way it evolves, in the internal processes that shape it, in the interactions that define its environment. And that realization forces you to let go of the notion that the solar system is a uniform structure with minor variations, and instead accept that it is a collection of unique histories, each one shaped by conditions that may not repeat elsewhere. And then comes the part that truly breaks the intuition, because you might expect that as you move farther from the sun, everything would become simpler, more stable, less active, but the opposite begins to emerge. Extremes appear where moderation was expected. Motion becomes more pronounced rather than less, and processes continue in places where they should have faded long ago. Revealing the distance does not simplify the system. It exposes different mechanisms: internal heat that persists over billions of years, gravitational interactions that operate quietly but continuously, shaping worlds in ways that are not immediately visible until you are close enough to measure them. So what looked at first like a straightforward mission, a sequence of flybys through 4 distant planets, turned into something far more significant, because it was not just a journey through space. It was a journey through layers of misunderstanding, a process of replacing a clean, simple model with something messier, more interconnected, and far less intuitive. A system where energy is redistributed rather than lost, where structure emerges from interaction rather than isolation, and where each new observation forces you to reconsider what you thought you already knew, until eventually the original picture cannot survive at all, and in its place remains something more complex, more dynamic, and far closer to the way the universe actually works. There's a moment in every machine's existence that never announces itself, never arrives with a clear boundary or a dramatic shift, but quietly begins the process of ending everything it was built to do. And the unsettling part is that by the time you notice it, it has already been happening for years, maybe decades. And that is exactly where Voyager 2 is now. Not at the point of failure, not at some sudden collapse, but deep inside a long, irreversible decline that was understood from the very beginning and yet still feels strangely personal when you look at it closely. Because here's the thing I want you to hold on to. Voyager 2 is not running out of time in the way living things do. It is running out of energy. And in physics, that distinction matters, because nothing decides to stop. Nothing gives up. Every system continues exactly as long as it can be powered. And then, step by step, function by function, it begins to shut down, not all at once, but in a sequence of choices made by engineers who are, in a very real sense, deciding which parts of the spacecraft are allowed to continue existing a little longer and which parts must go dark forever. At the center of this process are three small devices that have been working continuously since 1977. Radioisotope thermoelectric generators, which is a complicated way of saying that the spacecraft carries its own source of heat produced by the natural decay of plutonium, 238, and that heat is converted into electricity, not efficiently, not abundantly, but steadily, like a slow-burning fire that cannot be extinguished and cannot be refueled. And when the mission began, that system produced around 470 watts of power, already less than what you casually use without thinking, but in the vacuum of space, with careful design and discipline, it was enough to sustain an entire interplanetary mission. Now, this is where the decline begins. And it does not begin with a failure. It begins with a law of nature, because plutonium-238 has a half-life of about 88 years, which means its power output decreases continuously, not in sudden drops, not in dramatic losses, but in a smooth, unavoidable curve, losing a small amount every year. And that sounds insignificant until you realize that on a spacecraft where every watt has been accounted for, even a slight reduction forces a decision. And those decisions do not remain isolated. They accumulate, forming a pattern that, over time, starts to resemble something very close to dying. So what do you turn off first if you want to keep the mission alive? Do you shut down the instruments that measure particles, or the ones that track magnetic fields? Do you turn off heaters that protect components from freezing? Or do you accept colder conditions to preserve power for communication? These are not abstract questions. They are real trade-offs that engineers at NASA's Jet Propulsion Laboratory have been making for decades, gradually shutting down cameras, spectrometers, and systems that once defined what Voyager 2 could do, each shut down permanent, each one narrowing the range of possibilities, reducing the spacecraft not through damage, but through deliberate sacrifice. And that word, sacrifice, becomes unavoidable when you realize that the only thing that truly matters now is the ability to communicate. Because without that, the spacecraft is no longer part of a system that includes us. It becomes something else entirely, something we can no longer interact with. And so everything is prioritized around maintaining that fragile link. A radio signal transmitted with about 22 watts of power, comparable to a small household bulb. And by the time that signal travels more than 20 billion kilometers to reach Earth, it arrives with less energy than the impact of a falling snowflake. And yet we can still detect it, still decode it, still extract meaning from something so faint that it almost seems impossible. And that alone should tell you how delicate this connection has become. But it will not last. And this is not speculation. It is calculation, because there will come a point where the available power drops below the threshold required to operate the transmitter. And when that happens, there is no gradual fade that we can adapt to, no slow transition we can respond to. There will simply be a final signal, one last transmission that takes more than 19 hours to cross the distance between the spacecraft and Earth. And after that, nothing, no reply, no confirmation, just silence, absolute and irreversible, because there is no way to send energy back, no way to restart what has shut down. And I want you to understand what that means in physical terms, Because once Voyager 2 stops communicating, nothing about its motion changes. It does not slow down. It does not drift differently. It continues exactly as it was, moving through space at tens of thousands of kilometers per hour, carrying all of its structure, all of its history, but none of its function, crossing a boundary that you cannot see, a transition from something that participates in our world to something that exists entirely outside of it. So when we say Voyager 2 is dying, what we really mean is that it is losing its ability to interact, to measure, to report, to remain connected. And that process is already well underway. Not as a dramatic ending, but as a slow narrowing of possibility, until eventually there is only one thing left for it to do: continue moving forward through the dark. Exactly as before, but no longer able to tell us that it is still there. Imagine compressing the entire history of human civilization, everything from the earliest cave paintings to the cities you know today, every language, every idea, every conflict and discovery, into a single stretch of time, and then realizing that what we are about to talk about makes that entire span feel small, not metaphorically, but in a very literal and measurable sense. Because once Voyager 2 moved beyond the region where the sun's influence dominates in the way your intuition understands it, the hardest thing to grasp is no longer distance. It is time. When it crossed into interstellar space in 2018, it sounded like an ending, like a milestone that marked completion, as if something had been achieved and concluded. But that impression is misleading, because nothing actually ended at that moment. There was no boundary in the physical sense that signaled a transition from one phase to another. Only a gradual shift in environment, a thinning of solar influence, a change in particle density, a subtle redefinition of where one region gives way to another. And in reality, what happened was not the completion of a journey, but the beginning of one that stretches far beyond anything that can be meaningfully framed within human experience. Because surrounding what you casually call the solar system is something far larger and far less tangible, a vast, diffuse structure known as the Oort cloud, not a clean edge, not a defined shell, but an enormous spherical distribution of icy remnants left over from the formation of the planets, extending outward to distances so great that ordinary units stop being useful unless you are willing to abandon intuition entirely. And despite everything Voyager 2 has already accomplished, despite the decades of travel and the billions of kilometers behind it, it is still nowhere near the far reaches of that structure in any meaningful sense. Right now it sits at a distance that sounds enormous when you hear it, more than 100 times farther from the sun than Earth is. And yet to reach even the inner boundary of the Oort cloud will take centuries, not decades. Not something that fits within a single human lifetime, but hundreds of years of uninterrupted motion. And that is only the beginning, because crossing the full extent of that region could take tens of thousands of years. And this is the moment where your intuition begins to fail, because you are no longer comparing distances between places. You are comparing entire eras of existence. 30,000 years ago, humans were painting animals on cave walls. There were no cities, no written language, no agriculture as you understand it. And everything you recognize as civilization simply did not exist yet. And that entire span of time fits inside the journey Voyager 2 will take just to move through one extended region surrounding our own star. And during all of that time, it will not be exploring in the way you normally think about exploration. It will not be transmitting data. It will not be responding to anything. It will already be silent, long past the point where it can interact with us, continuing forward only because nothing is there to stop it. And that is the part that changes how you think about space. Because we tend to focus on distance as the primary barrier, something that can be measured, something that might one day be reduced with better technology. But time on this scale is different, because it places the journey outside any framework of relevance, outside planning, outside purpose, into a domain where motion persists without meaning, where the object continues not because it has something left to do, but because inertia does not require intention to exist. So when you think about Voyager 2 leaving the solar system, it is not simply moving from one place to another. It is entering a regime where the concepts that defined its mission no longer apply, where there are no destinations in the human sense, no timelines that align with expectation, only a trajectory extending forward through a region so vast that even after everything it has already done, it is still, in a very real sense, just beginning, moving into a span of time so large that if you try to hold it all in your mind at once, it slips away, leaving behind a single, unsettling realization that what felt like a long journey to us was only the smallest fraction of what still lies ahead. At some point, without you noticing exactly when it happens, the idea of a destination begins to lose its meaning. Not because there is nowhere to go, but because the scale stretches that idea until it no longer fits the way you instinctively understand movement. And this is where Voyager 2 is headed now, into a future where it will pass near stars, not arrive at them, not slow down to enter orbit, not even meaningfully interact, but simply drift through their neighborhoods the way a particle of dust might cross a beam of light without ever becoming part of it. If you try to imagine this journey the way you would imagine traveling on Earth, moving from one place to another with a clear endpoint and a sense of completion, you will immediately misunderstand what is actually happening, because Voyager 2 is no longer navigating toward targets. It is following a trajectory that was set decades ago and will continue almost unchanged for hundreds of thousands of years, shaped only slightly by the gravitational structure of the galaxy. And along that path, there are moments that sound like encounters when you describe them. But in reality, they are nothing more than instances where the spacecraft happens to be less far from one star than from others, which is a very different thing from arriving anywhere. Take one of the earliest of these future encounters, a small red dwarf star known as Ross, 248, which Voyager 2 is expected to pass in roughly 42,000 years. And I want you to pause on that number, not because it is large, but because it already places the event completely outside any human timeline you can meaningfully relate to. And even then, when that moment finally occurs, the spacecraft will still be about 7 light years away from the star, a distance so vast that light itself takes nearly 2 years to travel across it, meaning that nothing resembling a meeting will happen. No exchange, no capture, no change in state. Just two objects continuing along their paths, briefly closer than usual, and then separating again. And the pattern does not end there, because if nothing disturbs its motion over much longer time scales, Voyager 2 will eventually pass within a few light years of Sirius, the brightest star in your night sky. But again, the word pass is misleading if you take it too literally, because it does not imply proximity in any everyday sense. It does not imply arrival. It simply marks a point along an endless curve through the Milky Way, where for a short span of time, measured in thousands of years, the spacecraft will be marginally closer to that star than to others before continuing onward into regions that are just as empty and just as indifferent. This is where the journey becomes something fundamentally different from anything you usually describe, because there is no final destination waiting at the end of this path. No place where Voyager 2 is supposed to stop or complete its mission. Instead, it becomes part of a much larger motion, orbiting the center of the galaxy itself, taking hundreds of millions of years to complete a single revolution. And within that scale, the idea of an individual trajectory begins to blur, because over enough time, paths overlap, positions change, and what once seemed like a unique journey becomes indistinguishable from countless others moving through the same vast structure. What makes this difficult to accept is not the physics, because the physics is straightforward. Inertia carries it forward. Gravity shapes its path. Nothing mysterious is happening, but the absence of intention. The fact that this motion continues without any requirement for arrival, without any mechanism for conclusion, and without any observer who will be there to witness it, transforms the idea of travel into something almost abstract, as if movement has been separated from purpose, as if the act of going somewhere no longer depends on ever getting there. So when you ask where Voyager 2 is going, the honest answer is not a place, not a star, not even a region, but a process, a continuous unfolding of motion through space that will outlast not only the spacecraft's functionality, but any connection it ever had to the civilization that created it. And the more you think about that, the more it forces you to reconsider what it means to travel at all. Because in this case, going somewhere and never arriving are not opposites. They are the same idea stretched across a scale so vast that the difference between them disappears entirely. By the time you reach this point in the story, something has already shifted in the way you think about Voyager 2, because it is no longer a functioning spacecraft in your mind, no longer an explorer sending back data, but a silent object moving through a space so vast that its original mission feels almost insignificant. And yet attached to it is something that was never meant to serve that mission in any practical sense at all, something that does not help it navigate, does not help it survive, does not help it communicate with us, and yet may outlast everything else we built into it. And that is where this story stops being only about physics and starts becoming something else entirely. Because bolted onto its structure is a golden record, a 12-inch gold-plated copper disc that sounds almost trivial when you first hear about it, as if it were a symbolic gesture added at the last moment. But that interpretation misses what it actually represents, because this object was designed with a time scale that does not match the spacecraft, does not match the mission, and does not even match human civilization. It was designed to endure for up to 1 billion years, long after every instrument has shut down, long after the power source has faded, long after the structure itself has been worn down by dust and radiation, and long after anything you recognize as the present world has changed beyond recognition. And I want you to pause on that contrast, because it creates something deeply unsettling and strangely beautiful at the same time. The machine that carries the record will fall silent within decades. Its ability to interact ending quietly and without ceremony. But the message it carries may persist for geological timescales, drifting through interstellar space long after the context that created it has disappeared. And that tells you something important about intent. because whoever designed this knew that the probability of it ever being found is vanishingly small. So small that it approaches zero in any practical sense. And yet they included it anyway. Which means the purpose was never purely functional. It was expressive, almost philosophical, an attempt to say something in a universe that offers no guarantee of being heard. The contents of that record reflect this choice in a way that is unmistakably human, because instead of filling it only with technical data or scientific descriptions, it carries images, sounds, fragments of experience, mountains, oceans, cities, a woman holding a child, not because these things are universally meaningful, but because they are meaningful to us, and that distinction matters, because the message is not simply, this is how our planet works. It is, this is what it felt like to exist here, which is a very different kind of statement. One that carries emotion as much as information. And then there are the sounds, not just language, but the ambient noise of life itself. Wind moving through air, thunder, animals, greetings spoken in dozens of languages, some of which have already disappeared, and embedded among them is something even more intimate. The sound of a human heartbeat, the physiological trace of a person experiencing something as personal as falling in love. And when you realize that this is traveling through interstellar space attached to a silent machine, it changes the entire character of the story, because now it is no longer just a record of facts. It is an imprint of experience, a fragment of what it was like to be alive at a particular moment in time. What makes this even more striking is that the record includes instructions, diagrams etched into its surface explaining how to play it, how to interpret the signals, even how to locate its origin using pulsars as reference points. And this is where the contradiction becomes impossible to ignore, because extraordinary effort was made to ensure that the message could be understood, while at the same time fully acknowledging that the chance of anyone ever encountering it is almost non-existent. And that tension between effort and probability is the core of what this object represents. Because in the end, the universe does not respond. It does not acknowledge. It does not confirm that anything has been received. Voyager 2 will continue moving. The record will continue traveling with it. And most likely nothing will ever interact with it in any meaningful way. And yet the act of sending it was never about certainty. It was about possibility, about making a statement that does not depend on being heard to have value. So when you think about Voyager 2 now, far beyond the reach of any human intervention, what you are really looking at is not just a machine drifting into the void, but a message carried into silence. A declaration that says, in the only way we knew how, that we were here, that we observed, that we felt, and that even in a universe that offers no guarantee of being noticed, we chose to speak anyway